So yeah, I guess we are ready to go to the open discussion. So if people want to come up with more questions for Vladimir or somebody else from the speakers, now it's the time to do so. And also I can invite more people to the panels in case they want to share some screen or discuss. So if there's somebody who wants to talk or show some slides about something to share his ideas, let me know so that I can add him now. And yes, apart from that, just since we had the Vladimir's presentations at the end, it was quite dense. So there are many points, as you mentioned, that Calcite could help in better integration. So I guess the next step is to create Ziras and start discussing them on how we bring back and how we can make your life easier in Hazelcast. Since you mentioned that there are many points that need extra work.
Yeah, you know, I would say that perhaps many of the points raised is very specific to the Hazelcast. So if we faced some problem, it doesn't necessarily mean that anybody else will need that. On the other hand, yeah, I think that some of the things that we found could improve the product for others, right? So yeah, definitely, I will follow up on this and provide the specific places and examples. But it will take some time, you know, to extract the code, to prepare the reproducers or so. I do not want, you know, to ask you to look at the Hazelcast code. I would like to prepare it.
Yeah. So Vladimir, I thought your constructive criticism was great. I think it's, you know, I wrote a lot of code. For example, converting SQL literals to Rex nodes, right? I wrote that code years ago. I don't think about it anymore. And it's only when folks like you have to use it and notice the problems with it that, you know, we come back and, you know, improve it, refactor it to make it better. So your constructive criticism is really helpful for us. And I would suggest the next step would be to log some Jira cases about just write the cases. Don't provide pull requests, but just provide the cases about what improvements you'd like to see. And I think your talk provides all the necessary context for people to understand why this, you know, making, let's say, conversion of SQL nodes to Rex nodes, to making that pluggable would be a useful thing. So yeah, I love when people describe how they've used Calcite in real world products, because those of us maintaining Calcite are kind of as in a bubble, as isolated as everyone else, and it's really good to see, to get, you know, real world experience.
So here comes another question from Chunwei. Chunwei, let me allow you to talk also. Just let me, so that we have a more interactive dialogue. So I guess now you can ask your question live. You can unmute your microphone.
Okay. Hi, everyone.
Hey.
Yeah, I'm Chumule. Yeah, can you hear me?
Yeah, great. We can hear you.
Yeah, thank you. Yeah, I want to ask what's the advantage and disadvantage comparing to Orca? Yeah, because I never dive into Orca. Thank you.
Yeah, I wish there was someone from Orca here, like, you know, Haisheng, obviously. I mean, one difference that I know about is that Orca is written in C++, which makes it obviously less convenient in a Java environment. I think some of the algorithmic differences are beginning to decrease because people like Haisheng from the Orca team are on Calcite and are basically noticing the differences. And I think there's some features of Orca that they are missing. So, for example, the top-down optimization, I think is a feature of Orca that they're now bringing into Calcite. As for other specific differences, I don't really know. I mean, but both of the systems are based on Volcano/Cascades, and so they have similar heritage. The other thing about Orca was it was designed for a single. It was designed for a single system, that is for Greenplum, whereas Calcite was designed from, from the word go to be a kind of like a toolkit, and not assuming a particular that anyone was going to use it in a particular configuration. So I think that's an advantage of Calcite, although Vladimir's feedback indicates that we can still do more to make Calcite pluggable.
Yeah, I was gonna say also that there are other open source database systems, like Postgres is open source. So if I know people that took out the optimizer or tried to take out the optimizer, and actually they implemented a system based on Postgres. So, but how easy is to do it? This is a kind of an important question. So Calcite is made, as Julian said, it was made for that, to be modulable and easily usable. We can do more on this, but if you try to extract parts out of a system, it's not that easy if it's not made for that since the beginning.
The other point I'd make about Calcite, which it diverges from the the simple introduction Stamatis gave today, but a lot of people are using Calcite as a kind of parsing and SQL translation toolkit, not really for optimization. And I tweeted out a diagram a couple of weeks ago that got quite a few likes on Twitter. I should include it in a presentation at some point, just describing the flow from parsing into SQL nodes to rel nodes and then back out to SQL. So if you want to use Calcite as an engine that can translate, let's say, MySQL SQL into Presto SQL, Calcite, you're not really using the optimizer very much for that. But our dialect support in terms of having supporting different syntaxes, different sets of operators, different type derivation rules. You can even use different quote characters for quoting your identifiers or string literals. Calcite has the richness in that area that I think other systems that are basically query optimizers are missing.
Yeah, like one thing that's worth mentioning among the many is that you can provide materialized view rewritings to systems that do not provide materialized views. So there are many things that Calcite has and we didn't cover, but we could cover in follow-ups. And of course, another example or another kind of question that I was having in mind when Julian was presenting his work about spatial implementation of spatial queries is like Calcite is very good in integration, so integrating different systems. So you can have I don't know, you can have a relational database, and on the other hand, you can have a search, a text search engine like Lucene or Solar or something like that, and you can create joins between them or other operations. So during the presentations, like the first thing that came to my mind was model. For example, I think that Lucene, for instance, or other data similar systems provide specialized indexes like R3s and KD trees for spatial data. So the idea that came to my mind, and you kind of addressed it during the presentation, was like modeling the index in Lucene, like a materialized view, and then you try to use the materialized view during rewrite, and kind of works like transparently. It was not the goal of the presentation, so I got it. But it's just to say that another strong part of Calcite is integrating different systems. So we should cover it in a follow-up meetup.
Yeah, the integrating systems, let's call it federation or something, was one of it was one of the things that motivated me to create Calcite. And I could see that any system that actually had its own attached engine was always going to want to store data in its own engine. And so Calcite was conceived as not being able to store its own data, and therefore it had to federate. It had to store data in other systems. It had to be able to talk to other systems. The other thing that I keep on encountering is, if you read the marketing materials of let's say a document-oriented database like Mongo, they will tell you that it's a document-oriented database, and document-oriented data is totally different than relational data. And yet, if you speak to the engineers that actually build a system like Mongo, or a system like Lucene that deals with text data, or a geospatial system, they will all readily admit that they're basically working in, relational algebra. Their core operators are relational operators. And they may, let's say 90% of the DNA of their system is relational, and then they have 10% extra stuff for documents or geospatial or whatever that system's, or streaming, whatever that system specializes in. Under the covers, these databases all look very similar to each other. At least at the logical level, they're doing data flow. They all have a filter operation. They all have a union operation. So there's a few details, but the core of this is very similar. And so one thing Calcite enables is allows you to see these other systems, queries for Elasticsearch, to see it as basically a relational query that utilizes some of the special features that Elasticsearch or Mongo has.
Yeah, that's actually a good point. Actually, I know of a couple of research works that are kind of trying to do query integration by modeling the different engines as relations, and then they apply view-based rewritings to do the job. So in this context, actually, Calcite could save a huge amount of effort. So you just model your data as relational tables, and then you leave Calcite do the job. And actually, one other thing that people miss sometimes is that they think relational data is just columns. But the SQL standard has evolved, actually from the beginning, I think. It had some kind of additional stuff like structured data types, array types, collection types, map types. And all this allows you to model quite some complicated structures. So you have people argue about JSON, XML, or other storage formats, but this could also be modeled in the relational world, let's say, using structs. And with the structs, you can have nested arrays of a structured object, and then it's kind of, yes, it's still SQL. So you can still query it via standard SQL.
So I agree with all of that. I think so SQL, has all this power to deal with non-relational data and nested relational data. I think it's fair to say, and people often say, well, SQL 92 doesn't have an array type. Yes, but SQL 99 does. It's fair to say that SQL is not the most attractive language when you're dealing with nested data and these non-relational data types. So something I'd like to see is supporting more languages than just SQL on top of Calcite's relational algebra. we have, for example, we have an implementation of Pig's language on top of Calcite's Algebra. And yeah, if I could draw an analogy with the way Microsoft has, Microsoft's .NET architecture is a single representation for programming languages, but there's languages such as C# and F# and VB, and probably many other languages, and Link, many other languages on top of this kind of backbone. And I see Calcite similarly. It's relational algebra in its core, and of course SQL is the main interface. But if you want to write a language that's really good at, I don't know, graph processing or deductive queries or document-oriented queries, or if you want to build a XQuery implementation, then Calcite's a pretty good place to start. And I would love to receive contributions of new front-end languages that translate directly to relational algebra. And then you'll be able to run your particular language on whatever backend Calcite supports. And to repeat, a good example of this is, I forget whether it's called Pig or Piglet, but it's an implementation of the Pig language that translates to Calcite algebra, and therefore you can basically run Apache Pig's Pig Latin language on literally any backend that Calcite supports.
Yeah, that would be a nice contribution. Let's see when it comes. Other part, while I was viewing the presentation from Vladimir, it was that he noted some problems with type inference, with the way that we implemented type inference in Calcite. It's a pity that we don't have Danny with us today, because he would have some nice hints on what is the problem here. But what I had in mind initially is that, like, there is also a mode that you don't have type reference at all, and this is the strictest that you can get. So if you wanted to be strict, I guess you could disable it entirely and rely on Calcite, right?
Yeah, that's been my inclination, is to do as little type inference as possible, which makes Calcite less. I think I've been persuaded over the years to add more, but I think initially, if you did write, 1 concatenate 2, I think it would not allow that, because you were trying to use the string concatenation operator on ints, and people kind of want implicit type conversions in cases like that. But
so I would say that the problem here is that there is no single right or wrong way of doing these implicit conversions. And the thing is that if, for example, you would like to disallow conversion in one operator, but still allow it in, like Julian mentioned, in concat operator, and basically this is exactly how we do this in Hazelcast. We restricted most of the implicit conversions, but still exactly in the concat operation operator, it is possible to basically implicitly convert almost everything into string. So this is solved on the case-by-case basis, right? So the problem that I mentioned is not about the behavior of the specific operators, right? Because as I said, to my opinion, there is no exactly one correct way of doing this. Every product should decide on its own how to do this. The problem is that sometimes the abstractions do not allow you to do what you want, right? So for example, you may overwrite the return type inference or how you check the operands, but then when you hit, for example, how the, let's say, cast operator with some specific literal is translated, you cannot do anything because the control is passed to the to some code that you cannot influence. So this was the problem.
Yeah, and another thing is that that caught my attention is that you said that when you, for example, have 3 integers and you try to do an addition, that you may get an out of bounds or integer wrapping or whatever. And what I was wondering is that normally I would assume that SQL standard defines these kind of things, how they should work. So I was wondering if, because you said that you are kind of making it more permissive by adding other rules, it means that you kind of derivate from the standard. I don't know if you checked at it. Because actually, when I was trying to implement a system based on using Calcite, I was trying to stay as close to the SQL standard as possible, because it can be the behavior can be easily documented. So you say you tell to people this is how SQL standard works, and you can go and look there. And when you start adding derivations here and there, you might get into corner cases that you cannot solve afterwards. Maybe that's just my.
I totally agree with that philosophy, and it's kind of, I'm motivated by laziness. If I'm using the standard, I don't have to write documentation. I can just say, go and look at the standard. Although the standard, often you have to, it's difficult to find a publicly available copy of the standard. And of course, the standard is not very easy to read. But yeah, that general principle of relying on the standard has been successful for us. It's often good to rely on to also say, for example, what does Postgres do? Because Postgres tends to do the right thing most of the time, and is way better documented than Calcite is. But I think one of Vladimir's examples was if you add together, I think it was 3 integers of I forget the exact, but it was 3 decimal tens added together, created a decimal something else. As far as deriving precision and scale of numbers, the standard does not take a very strong opinion about those kind of things, and so you're on your own. And it's definitely worth having other type derivation strategies if they work better in the real world than what's built into Calcite. There were a couple of things that the example of casting the time literal with where it has an extra second, and the converting 32,768 to a small int, those look like simple bugs to me. I hope they're bugs, and I hope we can just squash them and make them work right. I couldn't see any justification for why they did what Vladimir says they do.
Yeah. So basically, we were able to solve all these issues somehow. And as far as you note about the standard, that sometimes it just says that the behavior of the specific conversion or like is implementation defined. There are a lot of places in the standard that basically give up any rules on the type inference, right, and leave it to the actual implementation. That this is the reason why, if you would like to build the product that is, easy to understand and explain to users, then trying to tell that just look at the standard is not always a good option, right? Because some things are not covered by the standard, and that you mentioned, the standard is not freely available. So you may for sure ask them, users, to, let's say, download some draft from Wiki or so, but it is not very convenient.
Yeah, I wonder if instead of saying look at the standard, we could say look at this test. I think I'm rather proud of the Quidem test framework that we have, where the test is integrated. The test consists of SQL statements, but the expected answers to those SQL statements are embedded in the test. And therefore, if we were to write tests which where people can clearly read the SQL and they can clearly see what the output is, that might be a useful, it's quasi documentation, that if people want to know what Calcite does, they could read this test and see lots of examples of what Calcite does. Obviously, documentation would be better, but it's, given our resources, it's difficult to create documentation and keep it up to date. So it's something we should consider as a developer community, is writing tests in a easily readable script language like Quidim.
Yep.
Hey, Stamatis, do you? There were 3 questions that came up in the Q&A which we've not answered yet. Do you think now would be a good time for us to answer those questions?
Yeah, good point. I was having the panel open right now. So the first question says, what API calls are being sent to the Rel builder? What system is sending them? So this, I guess, because I was showing the slides that somebody can call Rel builder directly. Well, I was having in mind that like another Java client who is calling, who is building the plan programmatically. So instead of sending an SQL query that can come from a browser or another part, somebody could create the calls programmatically, the API calls, because some systems have built-in queries, for instance. And these built-in queries, they don't need to be necessarily in SQL. They can be written directly in a relational algebra by using the Rel builder. And yeah, in some cases, it's much more convenient. It gives you much more flexibility.
Yeah, I'd agree with that. And that pig language that we built it pretty much directly on top of Rail Builder, and it saved us an awful lot of work. There's one thing we need to do: SQL's own SQL to Rel converter, which converts the parse tree into relational algebra, doesn't use Rel Builder as fully as it could. That's an ongoing effort that I try and work on, to use Rel Builder for everything. I think we'd fix a few bugs if we use Rel Builder rather than creating Rel nodes directly. So that's something I'd like to achieve in 2021.
So let's go to the next question, which is, can you talk about rule-based optimization versus cost-based optimization? So I guess this is mostly, actually the question should be rather, can you talk about heuristic-based optimization versus cost-based Volcano-based optimization? Because both Volcano is rule-based, so you add your rules, and it's cost-based at the same time. So I think Vladimir also gave a hint on his presentation between heuristic optimization or cost-based and Volcano-based optimization, is that you have some kind of rules that you can, or simplifications that you could apply before going to the cost-based phase. And this is useful because, for example, that in most of the time, if you push the filters down as close to the source relation as possible, it would be good. So you don't need to check on the cost. And the argument is that you can use this kind of known rules that apply early on in the optimization phase as a separate phase, so that you don't need to include all kinds of rules in the cost-based phase. Because the more rules you put in the cost-based phase, then the longer the optimizer will run, let's say, because it has to explore a larger search space. While in the other alternative, you can divide it in phases, some completely heuristic, so you apply the rules till a fixed point, and some based on the cost. So my argument would be you can use heuristic-based optimization for well-known simplifications, pushing down projection filters, or other engine-specific optimizations. And you could also consider rec simplifications as part of this. Julian or somebody else want to add something on this?
Well, I just want to agree with you that real-world optimizers that are run in production systems are always multi-phase. And one of the wonderful things about Calcite's architecture is the fact that these rewrite rules are reusable, and you can use the, let's say, push filter through join rule in the logical phase, and then you can use it later in a cost-based phase. And now we have top-down optimization. We really have at least 3 different engines that can apply these rules. So the ability to reuse rules, writing a query rewrite rule is complicated. Every single one of them has hidden bugs and takes several weeks or months or years to stabilize. And the fact that you can use push filter through join rule in your own phase and combine it with other rules is really powerful. So yeah, go for a multi-phase optimizer, and you will, as your system matures, you will discover you need new phases. Perhaps you'll add a phase to do materialized view recognition towards the beginning of it. Maybe you'll add a phase towards the end where you want to do physical reoptimization because you know how much memory you have available for hash joins, that kind of thing.
I guess your last sentence, Julian, is also kind of related to the last question, or actually, yes, not the last, but a question that just came. If we can add a runtime plan reoptimization when the data sources are streaming and the execution is long running. So
yeah, it's interesting that this query optimization is not just a single phase where you work before the query. A query optimizer can only do a good job if it has good stats, and it rarely has good stats. If it's working on a streaming system, it certainly doesn't, because the nature of the stream can change. And if you're doing, let's say, a 10-way join, you don't have good stats because it's many way joins. It's just impossible to get good accuracy, good estimate of the number of row counts coming out of a 10-way join. So yeah, runtime reoptimization, which is what Slim is talking about, is there's a couple of ways to do it that, and I'd like to hear what Vladimir, if Vladimir's worked on the streaming SQL inside Hazelcast. I'd be interested to know what his take on this is. One thing that we worked on in SQL Stream was this idea that you produce a plan based on some assumptions. And if those assumptions turn out to be untrue, then you basically blow up the plan and create a new one. And then the challenge is now, how do you switch over from the old suboptimal plan to the new improved plan? And in a streaming system, if your streaming system has exactly one semantics, then you can basically use the recovery mechanism. This is, easier said than done, but that's one way of going about it, is switch over plans by assuming that one of your nodes just, exploded. I call it the hand grenade algorithm. Force the system into recovery, and when it comes back, adopt the new plan rather than the old plan. But there are the other form of reoptimization that I know of is, I think IBM has done quite a lot of research on this. It's kind of using SQL for ETL, where your query is actually a set of independent steps in the ETL process, and the first step would be to populate a temporary table, and then you analyze that temporary table, find out the statistics, and then you do further optimization later on when you have more information available. So I've just outlined, one thing that works for a streaming system, another thing that works for an ETL style system. So those are a couple of approaches. I'm not claiming that they each work for, as we say in Britain, it's horses for courses. You should use the approach based on what kind of system you're targeting.
Yeah, so to maybe a couple of additions to this. So first of all, I didn't work on this streaming part unfortunately, so I do not have any inputs for the streaming case specifically. But maybe an additional source of information that you may use to get some additional insights on this runtime reoptimization is to look at the sessions from the Andy Pavlov recent talks when engineers from different companies presented their approaches, and specifically you may look at the Snowflake database and you may look at the Spark, because they both apply different runtime reoptimization strategies. For example, in Spark, they may adjust the number of partitions dynamically if it happens that the result set is smaller or bigger than it was initially estimated during the planning and so on. So there is no simple answer, unfortunately, right? So the bottom line is that, yeah, during the during the optimization phase, you simply do not have enough information to produce the absolutely best plan, right? Because the statistics are almost always inaccurate, and this is greatly amplified either by the streaming nature of the query or by joins. So yeah, it is pretty common to reoptimize in runtime.
Okay, great. And I guess we can close with the last question, which says, what are the best practices for creating a custom logical operator class? So I may be wrong on that, but my first reaction would be it should be rather rare to create custom logical operators. From my perspective, I think it's reasonable to create custom physical operators or operators for specific conventions, but it's rather uncommon to create new logical operators. I would say, at least my first thought. And in any case, for the suggestion for best practices, I think the answer is look in the adapters code, in Calcite adapters, how do we do it? And of course, look in the systems like Hazelcast and other Hive or etc., who implemented their own optimizer, and they are rely on Calcite.
Yeah, I would agree with that. So the first thing, if you're creating a new operator, if it could extend from, I mean, I think someone is working on a new implementation of merge join, sort merge join. So that new operator is going to extend join. So the very first thing to do is, if your operator is obviously a subclass of one of the built-in logical operators, then subclass the logical operator. And the reason to do that is any rules that have been written for that logical operator, you will be able to inherit them. If you want to, you'll be able to write instances of those rules that work on your operator. So in the case of merge join, the push filter into join rule will apply to your operator if you've made your operator a subclass of join. So that's worth doing. The other thing is, if I just implemented pivot and unpivot, which are SQL operators, they're relational operators. The other thing to do is don't create a relational operator. I was able to implement pivot and unpivot as simply desugaring, so I was able to expand them to existing logical relational operators. So I didn't have to create, and I actually added some methods in Rel Builder, but they don't create a pivot or unpivot relational operator. They just create, you know, a collection of calls to aggregate and project. So the reason to not add logical operators is every logical operator, you have to write a lot of rules and test a lot of rules in order to make that operator interoperate with all of the other relational operators. So that's my other point, is if you don't need to create a new relational operator, don't. And number two, if you can subclass an existing relational operator, do that. And I still think there's probably only about 10 core relational operators that have lasted us for several years. And so it's unlikely that you will actually need to add a new one unless you're implementing a radically new kind of database. Like the one we added most recently, I think was, well, we added the nest operator, which basically allows you to represent a document database because it can deal with nested collections. And then we also added I forget what we called it. I think it's called repeat union. Basically allows you to do iterative queries. And, you know, that one operator allows you to do logical deductive queries in SQL. So each new operator adds a lot of power to the language, but each new operator requires a lot of work because you have to write all of the rules that will allow that operator to interoperate with other things. Oh, and yeah, last point. If you need a relational operator, see whether you can do it using a table function instead. You may be able to just use a what's it called, table function scan. So write a table function. The table function scan operator already exists, and your operator will just be a call to your table function.
So I guess we are good for the second session, and actually we are almost over time. So I would like to thank everybody for participating today, and I really enjoyed the discussions and the exchanges that we had. Hopefully we can repeat this. Actually, I will start the discussion on the dev lists for a next meetup around the end of April, and hopefully you can find some more presentations and people willing to participate. And of course, if there are still open questions or things that you would like to address, you can send them to dev lists, of course, to each one of us personally, if you prefer. And I would like to mention that for those people that didn't hear this, that the meetup is